Hi folks, Brian Benz here, Cloud Advocate at Microsoft, welcoming you to another JDConf 2024 on-demand session. In this session, Otavio Santana is going to talk about polyglot persistence. He's going to introduce you to NoSQL data types, including graph, document, and key value pairs. Then he's going to go on to show you how you can build persistence into your architecture and into your applications using projects like Eclipse JNoSQL, Jakarta NoSQL, and Jakarta Data. Enjoy.
Hello everyone, nice to see you all here. So my name is Otavio Santana, and today let's talk more about NoSQL database and how fascinating this kind of database is. Most of you might be familiar with relational database, right? Postgres, MySQL, and today we're gonna cover more about the enterprise way to look on NoSQL database. It's become more popular to handle with NoSQL database, to understand better how to achieve success using databases such as Cassandra, MongoDB, key value with Redis, and so on. So if you want to understand more and understand why we should pay more attention on this kind of database, this presentation is for you, okay? First, let's start and ask you why. Why you and we should pay attention on the persistence layer and why it's a super challenge to handle with persistence layer. Because it's the first thing that we do all the time. So we start our application. The first thing that we might do is the modeling. So we start the application with the database. That's the time where we have no idea about the business or the business is not mature enough. And then we need to keep doing refactoring. And what does that mean for us about refactoring? Refactoring for us in database means migrations. And it takes a long time to do it and make it happen. And of course, evoluting. So evolutionary data is important to any business perspective. And why I say that? Because it's important to understand why we should care about NoSQL database. And reply that and make it simple to be more adapt to the real world. There is this philosophy of polyglot persistence that looks exactly the same of the polyglot real person. So right now I'm speaking English, but I'm Brazilian, so I can speak in Portuguese at least. That means I'm capable to adapt to different environments. One with people who speak Portuguese and two people who speak English. As much language I know, more is my opportunities, my capabilities, my adaptability to handle with more people. And that's exactly what happened with database or the polyglot persistence. As much NoSQL database or SQL database I know, I can adapt to different situations. If I only know SQL database, that means I will only use SQL database. It doesn't matter if it makes sense or not. And of course, it also makes sense to NoSQL database, okay? But the main goal here is to go deep on NoSQL database. It's a huge universe. Right now, we're gonna cover the types. In NoSQL database, we don't have standards like we do have with SQL database. We have categories that defined by the way the information is stored in the database. Okay, and put that in mind that we have much more. So those are only the most popular and more mature ones. So white column, graph, document, key value, those are just the beginning of your journey with NoSQL database. We have more. We have multimodal. We have time series database and so on. So those, remember, are just a start point. As I mentioned to you, so NoSQL database are mostly of the time defined by the structure or the way that we store information in the database. Starting with the most simple one, the most straightforward one, we do have the key value. If you are familiar with Java, you might know map, where I do have a key, and based on that key, I can retrieve information, and this information counts as a unique information. And that's exactly what you do have with the key value database. So I have my key, I will retrieve information only by the key, and based on that, I will return the value as a unique blob value. Okay, so for example, here, as you can see, I love mythology. So I have 3 different keys. So I have Apollo, Ares, and Aphrodite, where I have my key, and based on that key, I will return my information as value. So Apollo will return sun, Ares will return war, Aphrodite will return love and beauty. So, and another point, there is no defined structure that you can put in the key value. Of course, as convention, please use the same structure, the same style, but mostly of the key value database are storage only a binary value or only text. So it's up to you to define the information that you're gonna put there. Here, of course, a sample of key value database, we do have Redis. With Redis, you can work with a scalable model, as you can see here. So I have the primary and then replica structure, where based on my key, I'm capable of generate a hash, and based on that hash, I go to the precisely point where my key is and read from the replica. So, for example, imagine that is the key Otavio. It will generate a hash. Based on that hash, you generate a slot value that is, for example, 2. On that case, I will go to master A and read from that replica, and so on. So that's the whole idea of, for example, Redis. So key value, Redis is the most popular solution of key value as far I know. And of course, if you want to work with horizontal scalability, you are capable to define the primary and replica structure way. Then let's move on to our second style, wide column, where pretty similar to key value, I have my key, where I'm capable to return the information, but and also I do have my value, but instead of have a huge unique value, I can take my information, break down in small pieces that I call columns. So I do have a Apollo that has 2 columns, dirty and color. Aphrodite, the key, I have 2 pieces of information, 2 columns, one dirty, another that has love and happy, weapon that has sword, and so on, right? So I have my key, I have my information in small piece called columns, and this column has the name and the information itself. Okay, of course, by convention, if you do have a column dirty and we storage a list of string, keep the same structure to another keys that has the column dirty. It's a convention, it's a good practice recommendation, of course. And as you can see, the columns might vary. For example, here just Apollo has color, and just Kratos has number of that gods, number of people who Kratos killed. Okay. Here is a sample of Apache Cassandra cluster. Of course, you do have more wide column family database. Cassandra is the most popular one, as far as I know. Cassandra works a different way, so it's gonna use the massless purpose, where there is no one in charge to read and write, so everybody is capable to read and write. What happened here is I have my clients. This client will take requests from a node. This node become a coordinator. Based on this coordinator, it will read information from a couple of nodes. So for example, here, I will read information from the node 1, node 2, node 7, and based on that, it will return for me. Based on the most recent information, I return for the client. Cassandra, to every column that I do have, it has a timestamp. This timestamp works as clock vector. The idea is, okay, let's take the one that has the highest value, because the column that had the highest value means it is the most recent information. So it returns to the client, but also it returns the most recent information to the node that participates on that discussion, that request, and that we call read repair. Okay, and you can use Cassandra with a single data center, multiple data centers, and so on. What matters here is Cassandra is one column, the most popular one as far as I know, and that's the way that Cassandra might like in your production application as massless architecture. So it doesn't matter. Everybody's in charge to read and write information from the instance from the server. And of course, they will communicate among these servers and data centers. Okay, I talked about key value, like a map, one column or column family that I do have my key, and my value is a small piece that we call columns. Right now, let's move on to the first more flexible NoSQL database that we're going to cover today. It is documents. Documents has one power that makes key value and white column jealous, because document is capable to read information more than the key. So on that case, document can read information, for example, from the name, from dirties, siblings, and so on. The structure of documents looks like a JSON file or XML file. On this case, of course, the JSON. And as I said, I'm capable to search a thing than the ID. So I can search by name, by dirty, and so on. So, and by the way, with document, I'm capable to have embeddable values like document inside documents that we call subdocuments here. Here, of course, we have a huge amount of document database. Here, it just with MongoDB, it's a sample. MongoDB is the most popular document database that we do have right now. And here, we do have the strategy of the primary nodes and replica nodes, where, of course, I have the strategy to write information from the primary node and read from the replica nodes. And of course, you are able to do the sharding based on the key. This way, you will split information the key based, so you can have the shard A responsible for information AB and so on. The last one type that we're going to cover today is a graph. The graph is one where you can have a huge search and analysis, because in graph, we can do a deep relationship, even deeper than relational database itself. Why? Because with graph, you can have directions of my relationship. So, for example, here, Kratos has killed Apollo, and Apollo was killed by Kratos. So, different directions, different meanings. And that's happened also with relationship, right? Because, for example, I'm here in Portugal. Cristiano Ronaldo is a popular soccer player here in Portugal, perhaps in the whole world. And it's not true because I know Cristiano Ronaldo. Cristiano Ronaldo knows me. So it has a direction of knowledge. And that sounds perfect with graph. I can explore graph, for example, when I need to put information on my relationships. I need to put direction on my relationship. So it's super special to you to explore and express the graph here in relationship engine and so on. Here, The most popular one so far I know is, of course, Neo4j, and it works like a leader and follower, or master slave, or primary replica. So we do have the leader who's in charge to write information and replicate this information, do the replication process, and we do have the read replica, exactly as the name said, to read information. Okay, right now I cover 4 NoSQL database. As I mentioned before, there are more. And every time we discuss to go deep on NoSQL database, beyond the types, we just understand that, okay, if I go to key value, I will have a huge scalability. So it might be faster, with more straightforward results and so on. However, the flexibility of queries, when I mention flexibility here, is about how powerful I can do with my queries. With key value, of course, as the name said, I'm only capable to return information by the key. So I have a huge limitation by the key. When I go to column, I have more capabilities, more power, so I can return information more than the key. I can return a small piece of my information, so I can return information just as a couple of columns. I don't need to return the whole information like I do have with key value. Sometimes the white column has a secondary index, allowing the inquiry more than the key value, but we do have several limitations. Then we do have time series document that's really, really close to relation database. So we're able to do queries by, for example, the name, the ID, doing some aggregation operations, perhaps some functions, and so on. And the last one, as I said, we do have the graph database where you are capable to do really deep queries and analysis. So on that case, you can see that we do have a huge trade-off among NoSQL database. So key value, more scalability. Graph, less scalability, but more flexibility. So it's on you. So for now, I explained a lot about the universe of NoSQL database. I explained a lot the universe of the types, the structure, the strategy, and so on. But we do have a huge challenge on NoSQL database, that is standardizations, standards. Why? Because as you can see here, to do the same thing, the exactly same thing that I want to achieve. So we do have 4 different NoSQL database of the document types: RonDB, MongoDB, Couchbase, or NDB. We are trying to do the exactly same thing, as you can see. So name value is the piece of information that we call document. And we're working to append those information. So the name value, name value, name value, name value, with different classes, different names, methods names, but the same goal. And that's why we do have Jakarta Jakarta NoSQL. The main goal of Jakarta NoSQL is to create standards to this universe of NoSQL database. Take here, for example, we also have, of course, key value database. For example, we do have Redis, React, InfiniSpan, and Oracle NoSQL, where I want to do exact same thing. So give the key, I want to store the value. Give the key, I want to store the value, and so on. So different classes, different nomenclature, different method nomenclature, and so on. But the goal is the same, that is storing information. And that's why we do have, or it was born, the Eclipse NoSQL, to simplify that communication. From now on, instead of I need to remember or memorize different classes to the same goal, I need to do it once. So document NT, do the operation, and will convert and translate to OrientDB, AroundDB, MongoDB, Couchbase, and so on. And the Eclipse NoSQL has support to at least 4 NoSQL database type that we cover today. So column family or white column, graph, document, and key value. Here is a sample. So I'm using here my Pokemon NT. As you can see, I'm using records. So it's a multiple NT here where I do have my ID, my name, and my location. And based on that annotation, I'm capable to injecting my template operate like a data access object. So I'm searching my Pokemon based on that. So I do have my AroundDB, I do have my MongoDB, I do have my Couchbase using the exactly same API. And with Jakarta NoSQL, our Jakarta specification that has focus to make easier our life between Java and NoSQL database, I can extend. So I can have a huge extensibility of the API. So by default, of course, we do have the templates. And based on that, I have extensions like the document template. They want to work with documents. And based on that, we have a specific by vendors like AroundDB template, MongoDB template, Couchbase template, because in NoSQL database, we do have several particular behaviors that matters for us. For example, AroundDB has Around query language. Cassandra has consistency level definitions. Elasticsearch has search engine, and so on. The goal here is to make it easier. So it's completable, okay to combine those specifications. So you can use Jakarta NoSQL with Jakarta data. And using the same analogy and the philosophy of the extensibility. So we do have the data repository, the include repository, pageable repository, and the NoSQL database repository. So AroundDB repository, MongoDB repository, Couchbase repository, and so on. Here, where I can go quickly and the way that we do have with Eclipse NoSQL. Eclipse NoSQL is a framework who use several Jakarta specifications. So to integrate with the user, we use both NoSQL and data. To handle with JSON, we do have JSON specification. To handle the dependency injection, CDI. To handle with configuration, we do have the Eclipse Microprofile. At the Eclipse NoSQL itself, we do have the mapping and the driver, where this driver works like an adapter to communicate with the specific driver of the vendor. So as vendor, we don't need to recreate any new driver. You can be able to use your own driver with this adapter to make everything working. And that is all for today. So if you want to know more, you can access my website, otaviojava.com, where you can have access to books, to tips, and more about me. And of course, thank you for being here. So it's a huge pleasure. If you want to know more about me, so my name is Otavio Santana, software engineer and architect, so Java champion, Oracle Ace. I've been JSP executive member since Java 8, as far as I remember. Apache and Eclipse committer, Jakarta and Microprofile committer, Duke Choice Award, SP Award, and I wrote several articles and blogs about Java, software engineer, software architecture, and so on. So that's all for today. Hopefully you enjoy. Hopefully you want to know more about NoSQL database and more about persistence layers. And of course, see you over there. Bye.
Thanks for watching. Check out this and more at jdconf.com.